Good morning, parents and students. I am sending you this short video, I promise it's a short one, to make everyone's life easier and so parents understand what we're doing in class. So we've been going over the last couple of weeks scientific method, showing how we develop each part of it. This is, parents, this is critical because for your students to get through the rest of middle school and especially high school, they are going to need to know this and it will be invaluable to them. So I took 10 minutes to write out what their homework assignment is. They should have this in their notebook. They've been given class after class to go over it, to formulate it. I put samples up on the board. I've read theirs out loud. I'm going to give you a sample of what they should have in their notebook, and that work should be transferred over onto their Jupiter assignment for homework. It was due last night. I'll give you till the end of the weekend. Actually, I'll give you till the end of today because I'm busy. And so it was due yesterday. And so I need them to write out their hypothesis, a materials list, and a procedure for this magnet lab that they're going to be starting on Monday. If they don't have this done by Monday, in their notebook, and have the notebook in class, and on Jupiter by today, their team or their lab group will not be doing the lab. They will be watching. I don't know what they're going to be watching, but they're going to be sitting there and they're not going to be doing the lab. So just parents, so you know, this was not a difficult assignment. They could have finished this easily in class over the last couple of days. If it's not finished, please, you speak with them. So here's a hypothesis. We're taking some magnets, some paper clips. We're testing magnet strength. So I wrote out this hypothesis. I've given this to the kids in class. If stacked magnets, 1 magnet, 2 magnets, 3 magnets, ABC, or as I said, on a high school lab, you'd be writing respectively ABC, are placed on a flat level surface or table 1 centimeter from a paper clip, then C would be 3 magnets. You no longer refer to it as stacked magnets. That's why you're giving it a letter. Then C will attract the paper clip and B and A will not, because as you increase the number of magnets, the magnetic force will also increase. That's your hypothesis. That could be done by anybody, given to anybody in any country, and they could read this and they could do the experiment. Now your materials, 3 small round magnets, 1 paper clip, and 1 small ruler. If you were given 3 paper clips, but you only used 1 and you write down 3 paper clips, you're going to lose points because you're not using 3 paper clips in the experiment. The materials list is only for what you're using in the experiment, regardless of what I have given you. Now here's your procedure. Place a single magnet on a flat surface, step 1. Step 2, place a paper clip 1 centimeter away from the magnet. Step 3, observe, record data, and repeat using stacks of 2 magnets and 3 magnets. And for step 4, do 3 trials of all 3 stacks of magnets. Now, I didn't write it in, but step 5 would be, that would be step 5. Oh, okay. I added step 5 and step 3. So as long as you're able to understand that, that's fine. So whether you make a step 5 or whether you put it on step 3, it doesn't matter as long as all the steps are there. Now, an alternative hypothesis I gave them, I said, boys and girls, you're making this much more complicated than it need be. You can use a single magnet and a single paper clip. If a single magnet is placed on a flat level surface, 3 different distances, which I don't like to use distance, and I told them this for an independent variable, but for this experiment they can. So if it's placed on a flat level surface, 3 different distances, 1 centimeter, 2 centimeters, 3 centimeters, ABC, from a single paper clip, then A, listen to what I'm saying, will be attracted to the magnet, while B and C will not, because changing distance will affect magnetic strength, okay? They could have said that C is going to be attracted, and A and B will not. The idea is not to get the right answer. The idea is to perform an experiment, to test a testable hypothesis based on the materials given. You are not trying to get the right answer in an experiment. That's not the point of an experiment. You are trying to test your hypothesis. And for this alternative hypothesis, your materials would be 1 magnet, 1 paperclip, and 1 small ruler. Pardon my handwriting. And so in a case like this is all they had to do. And they should have had this by the end of yesterday. I gave them these same examples multiple times in class, and at this point, they should be able to just take that right from their notebook and put it into the Jupyter assignment. If they don't do the Jupyter assignment, or if they do not have their notebook with these 3 components in it on Monday or Tuesday for 632, they will not do the lab. Parents, I'm serious about this. They will not do the lab. I don't know what they'll do. They'll be sitting there looking at each other, wondering why one of them didn't do it, but they will not do the lab. And so make sure they have this in their notebook, written out. This is their homework. And on that note, everybody have a great weekend, and hope it doesn't rain. Doesn't look good. Okay, we'll talk to you soon. Bye-bye.